Okay, so this is a situation. There's 5 boys, 5 girls, and they're going to be put into seats. So how many ways can you do that if there are no restrictions? So basically, you're positioning 10 people. So if you think about this, it's just how many options do I have to put somebody in the first spot? You would have 10 options. Then on your next spot, you would have 9 options, okay, etc., etc. So then what would it shortcut to be? If I was going 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, it would be the same thing as doing a 10 factorial. All right, so that's going to be a big number. Do you remember the buttons? Okay, the next question says, we have to alternate between boys and girls. Okay, so if I go to put somebody in my first position, I actually still have 10 options because I could put anybody I want there. Okay, so now you have to pretend that you put somebody there, like a boy. So then if I went to my next chair, how many options would I have? So if I had placed a boy there, then this would be 5 options because now it's got to be a girl. Then if I am going back to a boy, how many boys would I have left? 4. Because I put one there. And then I'm back to a girl, so now I have 4 girls left. Back to a boy, there's 3 boys. 3, 2, 2, 1, 1. So I could put anybody there, but then here I had to put the opposite gender, so then there was only 5 of those, and then 4, 3, 2, 1. Okay, so if you really want a shortcut, the boys were 5 factorial, the girls were 5 factorial, but I times it by 2, that's where the 10 came from, because I could have started out with a girl, or I could have started out with a boy on the seats. So that's why that one got doubled at the front. All right, Zach and Andrew want to sit beside each other. So in this arrangement, they want to sit beside each other. So here's what I'm going to do. I'm going to clump them together. So when Andrew moves, Zach will also be moving with him. They're going to be moving together. So if I put them into the middle, this is all moving together. If I put them on the end, they're moving together. So you're going to treat them like one object. Okay, so how many things am I moving around? So I'm going to treat them as 1. So 2, 3, 4, 5, 6, 7, 8, 9. I only have 9 things instead of 10 things that I'm going to move around because they're chunked together. But within their little group, I could also flip-flop. I could be Andrew, Zach, or I could change to Zach, Andrew. So every time I move them, I could also be moving Andrew, Zach, Zach, Andrew side by side. So I could do that as well. So it's kind of like how many objects are you moving around, and then moving within the group yet. Okay, question D is the exact same concept. Okay, obviously the number is just different now. So let's see if you can do it on your own. It's the exact same concept. So C and D are the same question with just different amounts. Now there's just 3 people sitting together. So do it the same way, see what you can get. Okay, so I chunked the 3 of them together. So when I count objects now, I only have 8 things I can move around. Is that what you figured out? And then what can the 3 of them do? I can move them around within their own little section as well. So hopefully that's what you had figured out. Okay, this time they're going to be sitting in couples, so it's going to look like this. Those 2 are going to have to be chunked together when they move. So this is what it looks like. Each couple is glued together. So again, this is what you do. How many objects am I going to be moving around? How many different placement areas do I have now? I only have 5 because I'm moving around 5 couples. Then, what could couple 1 do? They could flip-flop. What could this group do? They could be flip-flopping. That one, that one, that one. So again, it's the same idea. This is the objects moving around. And then this is the within the groups. Okay, so this is a short way of doing it. You want to do to the 5th like that. You can do like that. Okay, the very last one. This time, Andrew and Zach must have had a fallout. They had a fight. They don't want to sit beside each other. Okay, so this strategy, you're going to do all the arrangements minus the opposite event. So this is called a complementary. A complement event is something that's opposite. Okay, because you're going to have a bunch of arrangements, and you're going to see that some arrangements, they're going to be sitting beside each other, and some they're not going to sit beside each other. So they're opposite of each other. Okay, so what did we do with the all arrangements? It's on our page already. Which question did we answer where it would be any arrangement possible? A, right? If there was no restrictions, this is how many arrangements there would be at all. Every arrangement possible is that. What's opposite of them not sitting beside each other? If they sit beside each other. And that's also on our paper. If they sit beside each other, so that was this event. So 9 factorial, 2 factorial. Okay, and then you can calculate that now. So does that make sense? It's just all arrangements minus the opposite event. That's a strategy. It's like some people, if they forget that and they try to do stuff on the test with trying to figure this out, it's kind of near impossible, because look at 2 million, you're not going to figure out beyond this strategy. Right, we're going to go one more page and then I'm done. Okay. A school has 8 doors to get into it. How many ways can you go into the building and out of the building? Okay, so I'm trying to go into the building. How many possible ways could I pick to go in? There's 8 options for me to go into the building. There's 8 doors. And, so I'm going to multiply. How many options are there for me to go out of the building? Also 8. I can go out any door. So there'd be 64 different ways I could do that. How many ways can you go in one door, but you would have to exit through a different door? So again, there would be 8 options for me to go into the building, but it says on the way out I have to pick a different door. So then how many options would I have? I only have 7 now. So then there would be 56 ways to do that. How many different PIN numbers are there with your debit cards? So those are 4 digits, your code, right? How many digits are there available for you to pick? You can use 0, right, with a bank code? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many options is that? 10. So there's 10 digits. Are you allowed to have repetition on your code if you wanted? Yep. So then there's 10 options on that, 10 options on that, and 10 options on that. Okay, we are allowed to use these digits. 1, 2, 3, 4, 5, 6, 7. How many different 3-digit even numbers less than 400 can you make? Okay, so let's talk about being less than 400. If I'm going to be less than 400, what are some options I could have here? I could place a 1, I could put a 2 there, or I could put a 3 here, right? So I'd have 3 available options for a digit there. Do you know what even means? To be even, you'd have to end. I don't care about anything else, just the end would have to be like a 0, 2, 4, 6, 8. So I have a 2, a 4, or a 6 available at the end. So I'd have 3 options. Because it doesn't say anything about repetition or not, so then like I could put anything, I could repeat too. So how many things could you put in the middle? I think you can put anything you want, right? So then I would have 7 options. We have 5 red, 4 black, 2 white cars. How many ways can you line up the cars if they need to be placed, if they need to place a red car on each end and the middle? Okay, so I'm just going to count here, 11 cars. Okay, so there's my arrangement. I'm going to have 11 cars. I need a red car on the ends and the middle. Okay, so I need a red car here, a red car here, and a red car here. How many options would I have to put a red car right here? I have 5 red cars to choose from. Then if I go to the middle, I'd have 4 red cars to pick from. And then at the end, I'd have 3 red cars I can pick from. Okay, so I've already placed 3 cars somewhere, right? So now I would have 8 cars left, and I can put anything anywhere now. So this would be 8, 7, 6, 5, 4, 3, 2, 1. Because any car to fill in anywhere else. Okay, so if I'm going to type this in, I'm going to do 5 times 4 times 3 times 8 factorial. That's what I would do. Right? Because 8, 7, 6, 5, 4, 3, 2, 1, that's the same as 8 factorial. All right, last question of the day. How many ways can you arrange this if the cars need to be put into their groups by color? Okay, so all the red cars need to be chunked together in position. So 1, 2, 3, 4, 5. So those 5 red cars have to be grouped together. The 4 blacks have to be together, and then the 2 whites. Okay, so we've run into this situation before. What would you do when you're moving this around? You do, how many objects are you moving around? Well, we're only moving 3 things around. We're moving black, red, and white. Then what's happening within? These 5 red cars could move around. The 4 blacks can move around, and the 2 whites can move around.